Construct a string from a binary tree. Given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree with the pre-ordered traversal way and return it. Omit all the empty parentheses pairs that do not affect the one-to-one mapping relationship between the string and the original binary tree. So first we notice in this question we want to do a pre-order traversal. And what is a pre-order traversal? It's when you visit the root, the left value, and then the right value. So in this example, it would look like, let me just clear this up, root, left, right. So in this example, it would just be visiting 1, then 2, then 4, and then lastly 3, which is a root, left, left, root, root left, then right. And that's exactly what our output looks like. And you see that every time you go left or right, you want to add these parentheses. So all the left values are grouped and all the right values are grouped. So we see this, it looks like a depth first search. So we can just use a depth first search for it. And we could just do a simple recursive solution for now because it doesn't really matter too much. The main idea is that you get the second part of the question. Omit all the empty parentheses pairs that do not affect the one-to-one mapping. So these are the orders: root, left, and right. In this example, we visit the root 1, then open parentheses because you're going left, then visit the next root 2, open parentheses 4, and then lastly close this parentheses, add 3. So for a tree that is similar to this but looks a little bit different, let's see how that would be. You would remove 4 here and add 4 over here. So before omitting any parentheses, what you would have is 1, 2, null is the left value because we moved it over, null, 4, and then 3. Notice we can't omit these empty parentheses because if we did, we would get this solution and we wouldn't be able to differentiate between the two trees. This is because we are doing a pre-order traversal, so the existence of a right value means you need empty parentheses on the left value. And that's basically the condition we want to have. So when do we keep empty parentheses? We keep empty parentheses for the left on 2 conditions. If the left is not equal to null, let's see, right. Left value is not equal to null, or the right value is not equal to null. Null or none, it's all the same. This is an or. And we only keep the right value if the right is not equal to null, because the right value doesn't affect the positioning of the left. These are basically the 2 conditions for if we keep empty parentheses. And with that, you can just solve the question quite easily with the depth first search. And the time complexity for this is O of n because we're going through n where n is the number of nodes. And the space complexity is on the call stack. You can do a recursive solution, which I'll show you. But you can also do an iterative solution. But let's just say the space is less than O of n. Some factor of it. Okay, now let's look at the solution. Here we have my Python solution for this question. So it's basically exactly what I showed you before. You want to start with the root value here. And then if the root left is null or the root right is not null, then you always want to add the left parentheses, even if they're empty. So this could be this. If root.left is none, this will be just the empty string, given the first condition we have here. And the right value, you only want to keep empty parentheses if the right value is not equal to none. So that's this case right here. We'd return root.val and then all this children. And you can submit the solution and you can see it's accepted. So thank you guys so much for watching. Always remember to like, comment, subscribe. It always helps the channel. The code will always be in the description. So make sure to look out for that. I have all code available now. So I'm doing C++, Java, and Python. So make sure you follow and subscribe to the channel because I'll be posting more regularly from now on. Thank you guys so much for watching. I'll see you guys in the next video.